doubt on how to solve a particular question, kindly let me know and I'll come back to you. So kindly go through those questions, learn to tackle them so that you can answer them the first time correctly. Today we move on to what is called the MRJT. Check your pen drives. MRJT. This is the last aircraft that we have to study. And once we finish this, then our portion for mass and balance will be completed. Now, we have reached in 031 our aviation exam right up till the end. But in between, there are quite a few questions that we have not yet been able to answer. So as we go along, I will explain to you all and we will learn how to answer the remaining questions. Currently, when you do your aviation exam, kindly attempt only those questions which we have, the portion which we have covered. So now looking at page 61 in your notes, and along with that, we will be referring to our CAP 696, figure 4.1 and 4.2. So yeah, this is the portion from our pen drives. I'll just go through that. Though it would be possible to locate components and parts of the airframe structure by actually measuring their distance from the CG datum, that is your reference datum, it would be difficult and impractical on anything other than a very small aircraft. Instead, aircraft are divided about their three axes, underline that, three axes, by a system of station numbers, water lines and bucket lines. So we have station numbers. Actually, for our syllabus, we are going to study only the station numbers as far as the longitudinal axis is concerned. Further on, when advanced studies are carried out on aircraft, there is the buttock line, that means vertical axis, as well as horizontal axis, that is analyzed station numbers. But we will be studying only the station numbers along the longitudinal axis. That is our syllabus. Even center of gravity we are studying only as far as the longitudinal axis is concerned. Now, the system of structural identification is not part of this subject, except to say that in the past, station numbers were used as balance arms about the datum for first kind of aircraft. So when the designers design a particular aircraft, it is called a prototype, the original design, and station numbers are given for that. What happens is, after a certain number of flying hours on that aircraft, certain modifications are made and the aircraft is changed. Though the basic structure remains the same, additional portion of the fuselage is added. So here it says, however, new variants of original series aircraft are often made by inserting additional lengths of fuselage, and consequently the distances of components and structure from the original datum undergoes a change. So if you have an aircraft, I want you to visualize, and the aircraft has to be extended. So what happens is the aircraft is cut in the center and a portion added. So 10 seats are added there. So the nose moves forward and the tail moves back and a new portion is added in the center. Now when this happens, obviously the original body station will change. And we know that body stations are balance arms. So the distance from the datum will change, obviously, because the aircraft has now become longer. Now there are two things. One is that you can keep the original station numbers and add a conversion factor, or give new station numbers. Now if you give new station numbers, then there will be a problem because there will be confusion. So what is generally decided is that you keep the original numbers constant. And when you add an additional portion of the fuselage, you give a conversion factor for that particular portion. So as it says over here, the station numbers could all be renumbered to enable them to retain their use as balance arms, but it is often more beneficial to retain original station numbers as they are. This means that on some variant aircraft, they can no longer be used as balance arms for CG. And in order to find out how far the particular station is from the datum, a conversion chart is required. So in order to use the station arms all throughout as balance arm, which is very, very convenient, we know that we have to calculate the centroid, center position, whatever portion maybe we are setting the center of gravity, and therefore a conversion factor is used. Now let's go on to your CAP 696 MRJT, page 1 of section 4, where you have the diagram of 4.1, figure 4.1 and 4.2. We'll study that a little bit. In the figure on top, which is 4.1, can you just get that up, please?
Can you scroll? I mean, I give you control.
No, it's not
okay.
in this. It's in the, yeah.
Oh.
CAP 696.
Oh, yeah, yeah, okay, this one.
Yeah, yeah. Yeah. CAP 696, go back. Yeah. It's section 1. This is section 6. We've got to go to section 1. Yeah. No. Section 4, chapter MRJT. Section 4, page is page 1 MRJT. Yeah. A little more. Yes. Yeah, this is figure 4.1. Okay. Very good. Now we'll study these two figures. Now here we have, this is for MRJT. Okay, data for MRJT. This is what we got to study now. This is, we've done the SCP, MEP. I hope you have done your questions, etc. That chapter is closed now. You have to keep revising on your SCP, MEP. Now we go to MRJT. So this is figure 4.1. Here you have an aircraft. Okay, this is called the front spar. And we know in our airframe we study spar is the connection between the wings. That center portion is the spar, that is the front spar. Here we have the nose. Can you see the datum over here? This is the reference datum. And two new portions have been added to the original fuselage. And that is between body station number 500A and 500G. Okay. And then the second portion has been between body station 7 to 7A and 7 to 7G. So this is the additional portion added and a conversion chart is given. Now it says over here body station 130 to 500. The conversion factor is body station minus 152. This is the conversion factor. It's worked out by the designers, the manufacturer, and given to us. So if we have to check the original body station 130, we have to apply the conversion factor to this 130, and the conversion factor is minus 152. Therefore, original body station 130, apply conversion minus 152, you get a new balance sum, that is minus 22. So we find here that the minus 22 is at the nose. So the original balance arm was 130. Now because you added this new portion of the fuselage and this portion of the fuselage, the body station has changed and we can still use it as an arm. So if we have body station number 500, what will be the new arm, balance arm?
348.
Body station minus 152, that is?
348.
348, very correct. So we got to check the balance arm over here from the body station. The new body station is 500A, B, C, D, E. The conversion factor has been applied over here, so we get the new balance arm. So if I were to ask you what is the balance arm for 500B, quickly got to look at this chart and say 392. And you'll be asked one or two questions in your examination, either this way or that way. Say if I say the new balance arm is 480, what is the original body station number? It is 500F. Similarly, you have for body station between 540 to 272, it is body station here is 0. We apply the same thing. 727, what is the new body station? 747. Balance arm. If I were to ask you what is the balance arm for 727, you just got to read. What is it? 831. So this is how we read the conversion factor from balance arm to body station or body station to balance arm. Is it clear? This picture is clear. This chart is clear. Now
Yes,
going back to your pen drives, you see on page 82, there is an example given. Convert 500E into balance arm. We can refer to that. Okay, that's worked out. Now try these figures. Okay. I'm going to keep the CAP 696 on. And each one refer to your page 62 and answer these 4 questions. Yeah, refer to this chart and answer these 4 questions. What is the station number at the nose of the aircraft? What is the answer?
Which page, sir? Again?
Page 62 in your notes.
Okay.
There are 4 questions.
Oh, okay.
Or above that, there are 2 questions. If you read that, convert balance arm. Just read it. What is 500E to balance arm is what? 500E balance arm is what?
500 balance is 458.
Yeah, simple. Convert 500E to balance arm 458. The next question is convert balance arm 809 into station number. Where is 809 over here? What is the balance arm?
727 delta.
Yeah, that's all. This is how you read the thing. Now there are 4 questions. Can you give me the answers?
No
What
station
is
is
the station
130.
number? Yes, 130. Because you're reading it from nose. From this nose, station number is 130. What is the next question?
Number 2 is 1217.
Very correct. 121. Very good. Read the next one.
500 golf. Number 3. Number 3 is 500G.
No, what is the distance of station from the datum? 500.
348.
348, correct? And last question.
787.
Very correct. So this is how you have to read this particular chart in your MRJT. So you should know in your CAP 696, if a question comes to you about body station, balance arm, conversion, any of these, words are there, immediately you turn to figure 4.1, 4.2, read it and get your answer correctly. So you have to learn from your CAP 696 where what is, so that you can immediately refer to it. Is it clear so far as 4.1, 4.2 is concerned?
Got it, sir.
Okay. Now, in your pen drives, look at figure 2.16. That is regarding your stabilizer trimming. Okay, before that, we'll come to this figure. Let me just go up. Yeah. Okay, this next 4.3, have a look at figure 4.3 here on your screens. It's a question of raising or lowering flap and change of moment. So here, if I am changing from 5 degrees, that means from 5 degrees down to 0 degrees. If I raise my flaps from 5 degrees to 0 degrees, my moment changes by minus 11 into 1000. So how much is that change of moment? From 5 degrees to 0 degrees, my moment changes how much?
11,000.
Yes, 11,000. Very simple. If it is, that is minus 11,000. Please remember that it is minus 11,000. So when I do some calculations, etc., later on in performance, you'll be using this thing, changing my flaps or lowering flaps. If I lower it from 0 to 5 degrees, what is my moment change?
11,000.
Plus 11.
Yeah, plus 11,000. Remember that. So now if I'm raising my flaps from 15 degrees to 0 degrees, what is the change in moment? Minus
Minus 14,000.
14,000. The other way around, if I'm lowering it from 0 to 15, the change in moment is plus. This it's important to remember these signs. And from to, so you got to remember and refer to this chart. Okay, 30 degrees to 0 degrees minus 15,000. For calculation, etc., you know, moment is very important. To calculate CG, total moment divided by total mass, you'll get your CG position. Therefore, you must know what is the effect of lowering the flaps, what happens to my CG, what is the effect of raising the flap, what happened to my CG, plus, minus, that is important, and the movement of CG will be accordingly affected. So any questions on chart figure 4.1, figure 4.2, or figure 4.3?
Sir,
Now
so so from figure 4.3, so which mean every time there's a movement of flaps, let's say flap retraction, it means like the CG is getting more forward, is it?
Yeah. There is always a change of center of gravity when the flaps are lowered, undercarriage is lowered. Okay, flaps are raised, undercarriage is raised, all those things are there. You will be calculating all that in your performance.
Okay.
Okay, but we need to know in our mass and balance, if we get a question, we refer to figure 4.3 and just calculate and give the answer. Very simple. Raising from 5 degrees down to 0 degrees up, the change of moment is minus 11,000. If it says change, lowering of flaps from 0 to 30 degrees, my change of moment is plus 15,000. This is what you got to be careful of getting the correct answer. How this is affected and all that, that will be in your performance. It's beyond the mass and balance calculations. Okay. Now this figure here, 4.4, is better drawn in your notes. I'll come to that after I finish this page over here. Okay, this figure 4.4, we'll discuss it on figure 2.16 later on in your pen drives. But since we are on this page, I will just cover the other information given over here. Now it says over here, mean aerodynamic chord MAC is 134.5 inches. What do we understand by this? What do you understand by this? This is what ABC, what is this?
CG ring?
No, this is mean aerodynamic chord. What is that?
From leading edge to trailing
From
edge.
leading. So the MAC leading edge is 625.6 inches. So on your notes, on your pages, draw an aircraft and put the datum and put your CG MAC front. Leading edge of MAC is 625.6 inches aft of datum. Draw that. 625. 0.6 inches aft of datum. Can we draw that figure? Over here on your notes, on your piece of paper, draw an aircraft, draw a datum, and put your leading edge of MAC as 625.6 inches. What will be the aft position of MAC? How far will it be between leading edge and trailing edge? How big is the MAC?
4.5.
134. So draw another line and put down MAC 134.5 inches. Okay, now we know that the MAC leading edge is 625.6 inches. Now I'll give you a question over here. CG position is 13% of MAC, 13. What is the CG arm? Can you work it out?
643.08.
Yeah. How do you work that out? 13% of 134.5 is how much? 13% of 134.5 is how much?
17.
Yeah,
48.
17.485. And therefore now the arm of CG, which is 13% of MAC for MRJT, okay, I can calculate what is the arm of CG. And therefore, when we do the calculation for our takeoff, our landing, we must ensure that the CG is always within the MAC. We'll refer to this later on. Okay, now there are some other information given over here. Maximum structural taxi mass, 63060 kg. These references will be taken when we do some calculations. If other references are not given and it is mentioned MRJT, then you should quickly be able to look in your CAP 696 and find out what is the maximum structural taxi mass, what is the maximum structural takeoff mass, maximum structural landing mass, and zero fuel mass. These are all structural limitation given by the manufacturer. Okay. Then we cover over here what is called the center of gravity for the aeroplane must be at all times within the limits prescribed by the CG envelope shown in figure 4.11. We'll come to that figure 4.11 a little later. Now here is some fuel data. We know this is the balance arm given for left wing. You look at the diagram. You have your left wing, you have your right wing. Okay, you have your main tank 1, main tank 2. So you have over here left wing main tank. You have your balance arm that is full, and this volume, forget it. And you have a mass, maximum fuel mass. Fuel in the left tank is 4524 kg. Right wing tank, it is 4542 kg. Center tank, 7008 kg. And total fuel, 16,092. And these are the centroids given for the different tanks. We know when we have to calculate our item mass arm moment, we can take from here references if it is not given in your question. The note it says here, if center tank contains more than 450 kg, the wing tanks must be full. Underline that or make a note of that. This is very important. If center tank contains more than 450 kg, wing tank must be full. So we have studied the fuel sequence in our airframe. We have seen the different center tanks. We've seen the wing tanks. We've seen the booster pumps. Various things. Now you got to correlate and understand how the fuel system is working, and what is happening to our center of gravity for calculation. So when we do some calculation for MRJT, we'll be referring to these charts. Then he talks about your wing tank. Okay, wing tank 1, wing tank 2 is given the location and the balance arm. Center tank, mass, kg, balance arm. These are the balance arms given for your center tank. Okay, so these are the things that we got to refer to as far as your MRJT is concerned. More about this when we do a little more calculations. Now have a look at figure 4.7. These are the different zones that the aircraft is divided in: Alpha Bravo Charlie Delta Echo Foxtrot Golf, and the passenger capacity. You also must have studied in your pressurization system that pressurization from the manifold is taken to different zones. And depending upon the passengers loaded on that particular day, the captain can control the cooling of the aircraft zone-wise. So sometimes when you're traveling, you find that, you know, passengers are few, it is very cold. You ask for blankets, etc. That is because the pilot is maintaining a temperature catering for 100% occupation. So there are different zones, and each zone has a capacity or number of passengers. A, B, C, D, E, F, G. Look at that. In the center there are more, and front and back there are different. So more of the passengers at the back, and each one balance arm is given. So we'll be referring to this figure 4.7, 4.8 later on. Okay. And these are the, just for information, not very much concerned with our center of gravity, but this is the information available. Passenger and personal data: maximum passenger load 141, first class 615, club class, business class 18, economy 108. This is the general structure of the MRJT. Now here we have a little information. Okay, very important. Make a note on this paragraph 5.5. This information about passenger, the flight deck crew and the captain, etc. Make a note over here. This is included in your DOM. This is included in your DOM. What is DOM?
Dry operating mass.
Yeah, dry operating mass. So this is included in your DOM. If you have your CAP 696, you can write it down over there. This is included in your DOM. So we are studying CAP 696. We should know MRJT, what is where. Then we studied this. You must have referred to this in your calculation of your cargo handling. The limits cannot be exceeded for cargo compartment, forward cargo compartment, or cargo hold number 1, forward, mid, and aft. These limits cannot be exceeded. Maximum running floor loading 68 kgs per square feet. Running load is given over here. Okay. So this is what we need to understand. Okay. Now, very briefly, we'll come back to this chart a little later. Very briefly, if you refer to your pen drive and go to figure 2.16, page 63, I'll quickly explain that. It's a graph that is given. Are you all there with me on figure 2.16 in your pen drive?
916.
Page 63.
Stabilizer trim setting.
Yeah, stabilizer trim setting. 63. This is 82. Yeah. Now this is a graph that is given, wherein it is very important to check the position of your trimmer. When we fly the aircraft for takeoff, we must have the correct trim. Now the explanation given here is figure 4.3, flap position. That is the center of gravity, and the movement of the flaps on large aircraft may have a considerable effect on center of gravity. Table 4.3 shows the movement changes of the aircraft when the flaps are extended or retracted. For example, retracting the flaps from 30 degrees to 0 degrees would cause the total movement change to 15,000 kgs. We've seen that. Conversely, extension of flap extension, remember that, underline that. Retraction is minus 15,000 and lowering is plus. So these two must be underlined, and you must remember this. And that chart in your CAP 696 figure 4.3, figure 4.4 is clear. Now what we are going to study here is so figure 4.4 in CAP 696. I want us to refer to figure 2.16 in your pen drives over here. Now you calculate what is your MAC for takeoff at that day, and then you lower your flaps to 5 degrees. Your trim setting will be 4.25 nose down. Okay, that means you have trimmed nose down. Okay, this is nose down. You have trimmed it on your MCP. I showed you the arrow for thumb operation for vertical speed, etc. Same thing over here. If I move the trimmer back, it is trimming nose up. If I move the trimmer forward, that is moving trimmer nose down. So that is the position, and I must check that my flaps are 5 degrees. My nose trim is nose down 4.25. Suppose I increase my flaps for 15 degrees that day for takeoff. Okay, we know that flaps can generate lift as well as generate drag. So for takeoff, I need a little more lift, so I will lower my flaps to 15 degrees that day because of various constraints, and I have to change my trimmer setting to 3.5 nose down. So this is the graph that we use for calculation of my trim position, depending upon MAC and flap selection. Now, can you all read if your MAC is 24%, okay, your center of gravity is at 24% MAC, and you are taking off with 5 degrees flap. What is your trim setting? How do you analyze this graph? What will be your trim setting?
3, sir.
Yeah, 3 degrees nose down. Please remember that. Okay, because it is gone, your thumb is moving from here to here, so you're going down, nose down. Clear?
Stop. Okay.
Okay, so this is what you got to refer to. Here is it. What is the table level? Stabilized setting 15 degrees move from 5 to, if it is moving from 5 degrees to 15 degrees, it is going. Okay.
Okay.
What will it be? If it is going from 5 degrees to 15 degrees, you are lowering it.
2.
So what's happening over here? From if the CG at 15% of flap setting is 5 degrees, then the stabilizer trim setting is 4.25 nose up. Okay. If the CG 15% max 15, then the stabilizer trim setting would be 3 degrees nose up. Now sorry, I made you're pushing the stabilizer down this way, not forward. You're bringing it nose up. Okay, it is changing. The stabilizer trim is changing. I'm confused, was confused. Now it is correct for it. Okay, you're moving it down. So it is moving from 4.25 to 3.5. So though it is going up, it is going, nose up. Please stand corrected. If I change my flap setting, my MSC is 15 and I am trimmer setting is 4.25 nose up. Then if I change my flap setting to 15 degrees MSC, 15 degrees flap for 15 degrees MSC, my nose up goes to 3.5. I'm moving the nose up, trimmer setting. Okay. Okay. Now, today I will also do some calculation of what is called the underload. So now we have finished seeing the CAP 696. And very briefly, we'll calculate what is called the underload. What do you understand by underload? Anybody? What is the meaning of underload?
Spare capacity.
It is the additional capacity. Today you have a certain amount of traffic load, but your aircraft is capable of carrying more load. That is called underload. The captain of the aircraft needs to know if he is able to accommodate any additional last changes to the total, that is VIPs, emergency evacuation, etc. So you are ready for your flight, and at the last moment you get an emergency call that there is a certain VIP to be transported, or there is some emergency evacuation, or certain members of the parliament have to go somewhere, whatever it may be. So you should be able to immediately calculate and tell beforehand calculate, and the captain should say, yes, I have capacity of last minute inclusion. So before the captain can allow any last minute addition to load, he must know if he has any spare load capacity or underload as it is referred to. So when you are sitting in the aircraft, the load master will bring what is called the load and trim sheet, which we will study later on. When you look at the load and trim sheet, you will be able to calculate what is your underload for that particular flight on that particular day. And it is not just question of simply having the difference between regulated takeoff mass and actual takeoff mass. Very important, the maximum zero fuel mass and traffic load have to be considered. So underline that in order to calculate underload, the captain has to take into consideration maximum zero fuel mass and traffic load must be considered. Now, clearly, now this is what you need to remember. If the aircraft is already at its maximum zero fuel mass, it has no underload. We know we've studied the maximum zero fuel mass in our definitions, etc. And we said that the wings, if there are no fuel, then the limited maximum zero fuel mass can be never be exceeded. So our underload cannot be, it is not there if I already have reached my maximum zero fuel mass. So when you are doing your calculation, DOM plus traffic load is equal to zero fuel mass. That zero fuel mass should not exceed the aircraft maximum zero fuel mass. And for MRJT, the maximum zero fuel mass is given in your CAP 696. You have to refer to that. So even if it is below the maximum zero fuel mass, any underload may have already been consumed by extra fuel uptake. So at any stage, the captain must know what is the underload available. And for that underload, it is not just a calculation of difference between the regulated takeoff mass and actual takeoff mass. The maximum zero fuel mass and the traffic load has to be considered. Therefore, there is a formula, and it is, you have to know what is called the allowable traffic load. Okay, the allowable traffic load is the, underline this, the allowable traffic load is the lowest of the following. You are required to know these formulas. So this formula must be known. Okay, so there is a formula called structural limited traffic load, takeoff limited traffic load, and landing limited traffic load. Now the lowest of these three is the allowable traffic load for that day for that particular flight. Okay, so here we have, how do I calculate my structural limited traffic load? It is maximum zero fuel mass minus DOM. Structural limited, that is the limit of traffic load I can carry. It's very straightforward. Maximum zero fuel mass minus DOM. Takeoff limited traffic load. Takeoff limited traffic load is RTOM. RTOM is regulated takeoff mass. So if regulated takeoff mass is not there, I take my structural limited traffic load. Calculate through structural limited takeoff mass. Okay, takeoff limited traffic load is structural limited takeoff mass. If my regulated takeoff, what is regulated takeoff mass? What is the definition of regulated takeoff mass? Anybody? What is regulated takeoff mass and regulated landing mass? Do you all remember? Regulated takeoff mass?
Lowest of the performance limited and structural limited.
Yeah,
DOM.
lowest of the two. So if that is not given, then you take over here for regulated, you take the structural table. So that minus DOM minus takeoff fuel. So this formula you got to remember. Structural limited traffic load is maximum zero fuel mass minus DOM. Takeoff limited traffic load is RTOM minus DOM minus takeoff fuel. We can calculate this takeoff fuel also. Landing limited traffic load is regulated landing mass. If regulated is not there, structural landing mass, and minus DOM minus fuel remaining. Okay, so this formula gives me allowable traffic load for that day. How much am I allowed? So when I know how much I am allowed, and according to today, I find that my traffic load is only so much. Difference between the two is my underload. So here is an example given. You can note it down, work it out. In case of MRJT aircraft, if the DOM is 34,300, takeoff fuel is 12,000 kgs, fuel remaining at landing is 4,000 kgs. Now you calculate what is your structural limited traffic load. Underline that traffic load. I'm calculating structural limited traffic load, takeoff limited traffic load, landing limited traffic load. Allowable traffic load. So it is zero fuel mass minus DOM. It is 17,000 kgs. My takeoff limited traffic load is regulated traffic load. If there is no regulated traffic load, then you have a takeoff mass. You have your structural limited takeoff mass minus DOM minus your remaining fuel. Okay, then you have your landing limited traffic load. regulated landing mass minus DOM minus remaining fuel. Is now the lowest of these three is your allowable traffic load. So in this, what becomes your allowable traffic load? Lowest of these three?
16,500.
16,500 kgs. But if the actual traffic load was only 16,000, you have 500 kg of underload. So if the requirement is to take 3 passengers, immediately you can say, yes, no problem, I can take 3 passengers. So you are required to know how to determine the allowable traffic load using the formula above. Is it clear?
Yes.
How to calculate your allowable traffic load. Now, I'll give you a little problem. Take down. In case of MRJT, DOM is 40,000. Takeoff fuel is 18,000. Fuel remaining at landing is 6,000. Actual traffic load 3340 kg. Can you calculate your underload?
Can you repeat again, sir?
Yeah, DOM 40,000. For
40.
MRJT, DOM 40,000.
40.
40000.
Okay.
Fuel 18000. Fuel, takeoff fuel 18000. Fuel remaining at landing 6,000. Actual traffic load today 3340. Using your MRJT figures, there is no performance limited takeoff mass or landing mass. What is your underload for today? Calculate your allowable traffic load, lowest of these three. Anyone got the answer?
Is it 660?
How much?
660?
No.
1460.
Yeah, 1460 is the correct answer. Good. Please do your calculations very carefully. So everybody should get the correct answer. And it says over here, you are required to know how to determine the allowable traffic load using the above formulae. Very important. You will get a question and you cannot use your diagram of, DOM plus traffic load equals 0 fuel mass. You have to know this formula. What is the formula? Lowest of structural limited traffic load, takeoff limited traffic load, landing limited traffic load. How do you calculate structural limited traffic load? 0 fuel mass minus DOM. And takeoff limited traffic load is RTOM minus DOM minus takeoff fuel. And regulated landing mass minus DOM minus remaining fuel. All these you can calculate provided you know your definitions correctly. Okay, what is takeoff fuel? How to calculate takeoff fuel? What is fuel remaining? If you have used up your trip fuel, okay, fuel burn, all those terminologies you must remember. So the formula is lowest of structural limited traffic load, takeoff limited traffic load, and landing limited traffic load. All minus DOM, minus DOM, minus DOM, and minus takeoff minus remaining fuel. Lowest of these three is your allowable traffic load for that particular day. And you know how much load you got on that day, so you can minus the two and get your allowable. You have the underload that day. That day my underload is so much. Okay, I'll stop here for this morning. You need to go through your CAP 696 to refer to all the pages. Refer to the different graphs, station numbers, conversion, very simple, how to change from balance arm to station numbers to balance arm or body station numbers. You know the station number is from the reference datum, that is also called your CG datum. Okay, all these things we must know terminologies, and we will meet again tomorrow. Do we have a class tomorrow? No.
Oh, no, sir.
We'll meet on Monday then.
Yes, sir.
Okay, if the MCO does not extend, then we'll meet in class. If the MCO extend, then we will come to know by tomorrow. Okay? Is it clear, everybody?
Yes, sir.
Okay, thank you. We'll call it off for today, and we'll keep in touch. Thank you,
sir.
everybody.
Thank
Be
you, sir.
good. Okay, see you.
Thank you, sir.
Thank you,
Have a
sir.
nice day.
Bye. Thank you.
Bye-bye, sir. See you.
Thank you, sir.
Bye.
So you carry the mouse? Okay.
Okay, I know you take it. Yeah.
Okay, sir.